Welcome back to Math 109, Plain Trigonometry. In this video, we're going to take a look at radian measure and how we can convert between degree measure and radian measure. So first, we're going to define a radian. A radian is the angle at which the arc length of a circle is equal to its radius. So if I take a circle, and angle we're talking about is going from the center of the circle, so I'll draw the horizontal line with standard position, and then somewhere in here, we're going to have the length of that circle in there. So that length there being equal to the length of this radius. That would mean that the angle there is 1 radian. And of course we can work with fractional radians in there. So in order to talk about converting between radian measure and degree measure, we need to first figure out how many radians there are in a circle. So we know that a full revolution would give us the circumference of a circle. And the circumference of a circle is equal to 2 pi times the radius. So it would be a full revolution. So if we divide by the radius, we're going to get, there's 2 pi radians. For 360 degrees. And we can simplify this a little bit and say pi radians is equal to 180 degrees. So the two that are ideas that are going to be most useful for us is 1 degree is equal to pi over 180 radians, or 1 radian is equal to 180 over pi degrees. So we can use these two factors to convert back and forth. So as an example, if I give you a 45 degree angle, and we want to know what that is in radians, we're going to use the fact there are pi radians, which I'm going to abbreviate RAD. Eventually, we're not going to use any symbol for radians. Pi radians to 180 degrees. That's going to be 45 pi over 180 radians. And we can simplify the fraction and get pi over 4 radians. In the same idea, I give you 9 pi over 4 radians, and I want to convert this to degrees. I'm going to use the fact there's 180 degrees for every pi radians. And the factors of pi cancel out. Also using a little bit of factor label technique, the radians cancel out. And I can cancel a factor of 4 in the denominator to get 45. So I end up with 405 degrees. Once we're able to convert back and forth between radians and degrees, we can use that to do all the previous trigonometry that we've done. Like finding the sine of an angle written in radians, we can convert to degrees and then work from there. So that's all we're going to cover out of section 3.1. In section 3.2, we're going to take a look at a couple of applications of radian measure.